All right, guys, on lesson 7-9, we're going to be examining some different situations and analyze some relationships between some independent and dependent variables in some real-world situations here, okay? And in this case, we're going to be studying the number of tablespoons compared to the number of teaspoons of baking soda. Okay, so it looks like, we got to find this pattern here of, how they're related here, okay? And in this case, when I look, this pattern I see pretty simply. We don't have any when there's none, but if I go to 1 tablespoon is 3 teaspoons. And if I look down here, 4 is 12. So I can see easily that I'm tripling this, 1 times 3, 4 times 3. So I know if I have 2 of these, I can triple it and get 6. If I have 3 tablespoons, I triple it and get 9 teaspoons. Which I know that means teaspoons are smaller. We know they're 3 times smaller, right? Because we need 3 times as much of the teaspoon to make a tablespoon. So there's that unit rate I like. Every one of these tablespoons is 3 teaspoons. So it says to describe our rule in words. We just kind of went through that there. So make sure you're writing this stuff here. The rule in words, the number of tablespoons. Multiplied by 3. Number of tablespoons multiplied by 3 will get you the number of teaspoons. Or when the tablespoons go up by 1, every time I go up by 1, these go up by 3. All right, so you can see they're tripling. You could write that any way you want it on there, but that's the base for the rule and how to describe kind of the situation and what's going on. So we have to write that into an equation. So write an equation for the rule. So again, when we're doing this, we're trying to find what do I do to x to get it to y. And again, we tripled. So we can just take 3 times x. Again, you can't see that very well. 3 times x. I don't need a time sign because it looks like an x. So we say 3x equals y. All we're doing is tripling that, and it equals y. And that's the main thing. We're trying to find that equation or that rule for what's going on. Okay. Now, the next thing in D, it says write the numbers in the table as ordered pairs. All right, so this would be ordered pairs 0, 0, ordered pair 1, 3, ordered pair 2, 6. Again, we're getting ready to graph this on the x and y axis. Ordered pair 3, 9, ordered pair 4, 12, and ordered pair 6, 18. Get those around there. And I'm just going to graph these points, guys. On the back, it's going to tell me here, we're going to flip over, we're going to plot the ordered pairs on the grid, and we're going to connect those points. And that's kind of on the back I wrote there. We'll flip it over and look there in a second. Again, I'll pause the video here if you need to get this written down. But hopefully you can easily see that they're just tripling the tablespoons to get to the teaspoons is the main thing we need to see there in that pattern, okay, and that rule for that equation. Okay? All right, so you're looking over at the graph. All right, so what I did was plotted all those points, 0, 0, 1, 3, 2, 6. And remember, that makes a straight line because it's at a constant rate. We know it's just tripling every time. So whenever I go 1 more teaspoon, I go 3 more, or 1 more tablespoon, I go 3 more teaspoons. Okay, it's always triple. So we know if things increasing at the same rate, it will graph as a straight line because of that constant rate. So it's the first example here. After we've graphed that, it says use your rule to find the number of teaspoons of baking soda for 25 tablespoons. So I've got to be able to plug this in. I know it's 3 times x equals y. We know the x was the tablespoons. Okay, that's the x-axis, and that's what they tell us. So I plugged a 25 in for x. 3 times 25 then, triple it. We get 75 teaspoons, excuse me, if I have 25 tablespoons. Okay, I should have 3 times more, they're 3 times smaller, so that makes sense. So describe any patterns that you see in this graph. Again, what I kind of see here is when you go over 1 on the x-axis, you go up 3 on the y-axis. Over 1, up 3, over 1, up 3, and that pattern just continues. So the graph is aligned because of that constant rate that we're increasing at. Okay, so make sure we're taking time to get this stuff written down and kind of more see those patterns and see why our graph looks why it looks.